And now recording. And share the screen. All right, so we're doing graphs now. Graphs, graphs, and more graphs. That's our main focus for the next 2 days. Okay, so I'm still according to schedule 8.3, 8.4. I may not get to 8.4. I think we're okay even if we don't. 8.3, we're doing lots of graphs. The quiz tomorrow will be on graphs. Okay. So again, we're scheduled for the exam on the 8th of April after we come back from spring break next week. Okay, so even if I don't get to 8.4, we're still good. If I lose a couple of days, I got all these extra days at the end. I just have to make sure I finish 8.5 by Wednesday the 7th. Okay, and I think I'll be able to do that. And so we push all of these back a little. That's perfectly fine. Okay. All right, so now we're going to try to graph stuff that looks like this. In fact, I'm going to make it even more complicated than that. I'm going to give you a more general case. Y equals a sine of bx minus c. I don't even like the way they write it. Okay, so I'm going to do it my way. You will have to do a little bit of extra work, but I want you to do it my way. Okay, it's more consistent with what we did before in terms of moving stuff left, right, up, or down. Okay, so I'll give you the most general case and then go from there. Okay, so the homework again was a little bit convoluted. Okay, so we're done with this. 8.3, 1 to 7, odd, 10A, 11A, 13 to 31, 33 to 39, 41, 43. So the highest number is problem 43. Okay, so I'll show you what it's about. Okay, so page 569. Okay, I'm not sure if I gave this to you earlier, but here it is anyway. So all graphs, variations of sine and cosine. I gave you the basics yesterday of the sine and cosine, and we're going to make it harder now. And we had to go up to 43, I think it was. Yeah, so there we go. Right, so we're not going to do any problems for a while. I have to do a lot of background stuff. So here are some background. So some review, some new stuff. Okay, so graphs. Of sine and cosine functions. Okay, now again, the way I'm going to present it is different than the text. There's nothing wrong with the text, but I think it's easier to do it my way, obviously. So I want you to get comfortable with my way. So I'll show you again the basic sine and cosine functions for one period. Okay. You can put these on your cheat sheet. Okay, almost all of these graphs for one period, we'll split them into fours. Okay, so this is one period, so you cut it in half, cut each of these in half, like so. Okay, so the period of the sine function is 2 pi, and then you kind of want to get used to cutting it into quarters. I first cut it in half, pi. Half of that is pi over 2, and then you count pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. Okay, sine of 0 is 0, reaches its maximum, then 0, minimum, 0. So it looks like so. Okay, so this is one period of the sine function. Y equals sine x. Right, so the basic sine function has an amplitude. And I'll abbreviate amplitude with amp. Amplitude is 1. Period, which I'll normally abbreviate with PER, is 2 pi. So one period of the sine function goes 0, 1, 0, -1, 0, 0, 1, 0, negative 1, 0. So 1/4 of the way, halfway, 3/4 of the way, and the full way. Okay, so we've already seen that. Okay, and now I'll draw you the basic cosine function, and then we're going to make it much harder. If you want to put these on your cheat sheet, you may. For cosine, again, the period is 2 pi, pi over 2, pi, 3 pi over 2, 2 pi. Okay, cosine of 0 is 1. And then goes to 0, negative 1, 0, 1. So that's one period of the cosine function. Okay. Now, in actuality, these keep going because it's periodic. So imagine if you copy and paste, paste, and paste to the left also, it keeps going on and on and on. Same thing for cosine. This is only one period. This one might be easier to see because it's peak to peak, but copy and paste, paste. So both of them keep going forever, okay? And I'll show you a little bit more of that. But let me go over one period of the cosine function. The cosine starts at 1, goes to 0, negative 1, 0, 1. Okay. Both sine and cosine functions, the domain is all real numbers, funny looking R. And the range is bracket negative 1 to 1. All right. Now, I mentioned this earlier. I'm going to call this the maximum. This would be a minimum. Y equals 0, that's going to be the midline. Okay. Same thing over here. Maximum, minimum, midline. So I'll give you my abbreviations. So this is the basic sine and cosine, but now we're going to do stuff that we're going to stretch it, shrink it, compress it, and all this other stuff. Okay, so here are my abbreviations. I'm going to write max for maximum, min for minimum, and mid for midline. Okay, so maximum, minimum, midline. So in parentheses, I guess you could say it's optional. That's how you spell the whole word, right? Maximum. But to make it shorter, I'll just say max. Minimum, min. Midline, the line right in the middle. So the midline here is y equals 0. Y equals 0. Okay, so for the basic sine function, it goes 0, 1, 0, negative 1, 0. Okay. For the cosine function, it goes 1, 0, negative 1, 0, 1. But we're going to stretch it and shrink it and do all kinds of other stuff. So in general, for the sine function, it'll be midline, maximum, midline, minimum, midline. I'll write this down. For the cosine, maximum, midline, minimum, midline, maximum. Okay. So now we're going to consider y equals a, and it could be either sine or cosine. So I'll put both of them. Sine, cosine being lazy. B, x minus c plus d. Okay, so we're going to mix this up. There's going to be coefficient front, and this is not one problem. Okay, it's just to make it more compact. It's either going to say sine of blah blah blah, or it's going to say cosine blah blah. It's going to work pretty much the same way. Okay, so we said last time the amplitude is the absolute value of A. Period is 2 pi divided by absolute value of B, he said. Okay, and we know from before, a long time ago, C is a horizontal shift, D is a vertical shift. Horizontal shift. Sometimes it's called a phase shift. And D is going to be a vertical shift. And we've seen that before, right? So now we're going to incorporate all of these things to our graphs. Okay. So I mentioned this yesterday a little bit. Amplitude is absolute value of A. Doesn't matter if it's a sine or cosine. Okay. The period is 2 pi divided by absolute value of B. Most of the time, this would be positive. And from a long time ago, right? C is a horizontal shift, sometimes called a phase shift, and D is a vertical shift. Okay. Now, the way the book does it is they generally put this all inside the parentheses. In other words, they sneak in the B inside. Okay, and they make you do some other funny stuff. I'm going to have you factor out the B, and I'll show you how to do that. Okay, that's a little bit different than the way the text has it, but this is more consistent with what we did before. All right, so that's going to lead us to the following. You're welcome to put all of this on your cheat sheet. Okay, the general sine graph and all this stuff. All right, so for a sine function, if A is positive, here's how the sine goes. So instead of 0, 1, 0, negative 1, 0, I'm going to say what it'll be in general. So it's going to go midline, maximum, midline, minimum, and then back to midline. Okay, so this is starting 0 the way, 1/4 the way, 1/2 the way, 3/4 of the way, and then the full way for one period. Okay. If A is negative, switch max and min. We saw that yesterday. Okay. A is positive. That's one that we like. Follow this one. Midline, maximum, midline, minimum, midline. If A is negative, switch to max and a min. All the midlines stay the same. There'll still be mid, 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 but max becomes min and min becomes max. Okay. For the cosine, just piggyback off of here, the basic cosine goes 1, 0, negative 1, 0, 1. But what is it in general? Once we start moving and all that, that looks like the maximum, midline, minimum, midline, maximum. So cosine goes like this for one period. Maximum, midline, minimum, midline, maximum. Maximum, midline, minimum, midline, maximum. Okay, this is the beginning of the period, 1/4 of the way through the period, halfway through the period, 3/4 of the way through the period, and the full period. And once again, if A is negative, A is the coefficient right here, switch max and min. Okay. So in other words, this becomes min. The midlines stay the same. But if the A is negative, that would be a min, midline, maximum, midline, minimum. Okay. You can put all this on your cheat sheet as a reference. All right. Now, most of these graphs, we're going to be asked to draw one period of the graph. Okay. So we'll have to answer for what x values will we have 1 period. Okay. I know I'm taking quite a bit of time. I'm used, you're used to seeing me just go straight to the problems, but we need to develop all of this ahead of time. For what x values will give us 1 period, and we also know what is the range. Set of y values. Here it's from -1 to 1, but it's going to change once I do all this stuff. Okay. For what x values we have 1 period? Well, here it's 0 to 2 pi. Here it's 0 to 2 pi. But again, because of all this stuff, it's going to change. So instead of going from 0 to 2 pi, you might go from here to here or here to here. And it's the range, instead of -1 to 1, it might move like this or whatever. So how do we figure all that stuff out? Okay. So that's what we're going to do. Right. So in general, we have to figure out what's 1 period. We're going to divide it into quarters. Okay. I want you to be able to label for me the beginning point, the ending point, and all the in-between points, halfway, quarter of the way, 3/4 of the way, and so on, right? Tell me where's the maximum, minimum, and so on. Okay, so one more time. This is the most general. The graphs actually start off easier than this, but so A, either sine or cosine, B, parentheses, x minus c plus d. I want you to make the equation look like this. Okay, a lot of them aren't going to look like this. It's going to be inside the parentheses. You're going to factor it out, and I'll show you how to do that. Okay, and again, the reason why I'm doing that is it's more consistent with stuff we've learned before. Okay, so I want you to make it look in this form. Okay, and dare I say, since I'm your teacher and I get to call the shots, you have to set it this way. Now, if you do it exactly the way the book has it, you'll get the answer right, but I'm not accepting it. Okay, you got to do it my way. I need to see that you have this. Okay? It actually makes more sense than leaving it inside, and I'll show you how to do that. Okay, so you definitely want to have something like this. Okay, again, you should be considered fortunate. If we were meeting face to face, you'd have to memorize all this stuff. Okay, so in that sense, maybe you're happy that we're in a pandemic where I'm supposed to make it quote unquote easier on you. And the way I'm making it easier is you can have a cheat sheet. Okay, sine goes midline, maximum, midline, minimum, midline. The most general cases like this: midline, maximum, midline, minimum, midline. However, if A is negative, switch max and min. Cosine, maximum, midline, minimum, midline, maximum. Again, if A is negative, switch max and min. Okay, so most of the time we're going to be drawing 1 period. Once you have 1 period, you just copy and paste and keep going. Okay, so how do we get 1 period? What is the range? Okay, now you might be looking at all this and say, I have absolutely no idea what you're talking about. That might be true. Then it isn't until we actually start some problems that we get the hang of it. Okay, so now we're finally ready to start some problems, even though I've used up quite a bit. Okay. Okay, what future courses do this? Well, your calculus course, you need this quite a bit. Okay, so we're finally ready to graph some stuff. All right, so we're going to focus on this quite a bit, and your quiz tomorrow will be based off of this also. Okay, so tomorrow's quiz, I'll give you something that looks like this. I think I'll probably give you 1 sine and 1 cosine one. Do all of this analysis. Right. All right, so number 1 has y equals 2 sine x. 1a, y equals 2 sine x. So right now, there isn't any c or d to worry about. Just a and b. See, I don't see any b. Well, we pretend the b is a 1. Okay, so the amplitude is the absolute value of this, which is 2. Okay. Here's a question. What's the b here? It's actually there. It's 1. Right, pretend there's 1. And the c and the d are both 0 right now. So we're not shifting it horizontally or vertically. Okay. In some sense, that should be quote unquote easy because you've already done that before. Okay. The first problems deal with this. Okay, the a and the b. You should already be familiar with the c and the d. C moves something left and right. D moves stuff up and down, right? And we've seen that before. So the period is 2 pi, or 2 pi divided by 1, which is 2 pi. All right, so for one period, I'm going from 0 to 2 pi, something I'm already used to. Okay, this is for x. The amplitude is 2. So here's how we find the range. We take the normal range of either cosine or sine, which is -1 to 1, but we're multiplying it by 2. Here's the way I'm going to write it. 2 times -1 to 1, which is -2 to 2. So the lowest is -2, the highest is +2. Okay. So here we go. Period is 2 pi. Cut that in half. Pi. Cut that in half. Pi over 2. This one, hopefully for this standard one, you should know this is 3 pi over 2. But if you want to know how to do it in general, you can take this 1/4 of the way mark and count pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, my range is from -2 to 2. This is my maximum. This is my minimum. Okay. I'm doing a sine. So the sine starts off at the midline, which is 0. Right now it's going to be 0. So when is it going to be off of 0? Well, when you add 2 or when you subtract 3, right? For now, it's going to be 0. Maximum, midline. Maximum is 2, midline. Minimum, midline. The minimum was -2. So there we go. Y equals 2 sine x. And just for contrast, here was the original sine function. I'll put that in green. Okay, the maximum was 1. The minimum was -1. And it makes sense. If you multiply by 2, well, the maximum that used to be 1 is now 2. The minimum used to be -1, multiply that by 2, you're now at -2. But all the zeros stay the same. That stays the same, that stays the same, that stays the same, because 2 times 0 is still 0. Right? So this was a change in the amplitude. Now how about B? Y equals negative sine of 2x. All right. Negative sine of 2x. By the way, when it's like this, okay, this is the original problem. I'm going to sneak in a 1. The coefficient is 1. So the amplitude is the absolute value of A. Absolute value of -1 is 1. The period is 2 pi divided by B. Okay, right now we don't have any C or D. So it's 2 pi divided by 2, which is pi. Right. So one period isn't going to go from 0 to pi, isn't going to go from 0 to 2 pi. It's going to go from 0 to pi. Okay. And again, that's in the x direction. This is x. Okay. The range is always for y. You already know that. So how come I don't say domain? It's not really domain because the domain is all real numbers. This just gives you one period, but then you can copy and paste it as much as you want to the left and to the right. So the range is still -1 to 1 because the amplitude is 1. So this graph isn't going to change how high and how low it goes, but it's going to either take the graph and scrunch it or make it spread out. Okay, so this one I had to go from 0 to 2 pi. This one I'm going to go from 0 to pi. So it's not going to be the scale. I'm basically going to draw the same, type of graph. But I'm going to go from 0 to pi. Right? That's one period. Cut it in half. Half of pi, pi over 2. Cut that in half. Half of pi over 2, pi over 4. Now I'll count pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Of course, reduce your fractions. Okay, I always want you to show me these 5 key points: beginning, ending, halfway, quarter of the way, 3/4 of the way. Max and min are 1 and -1, just like before. So I do that whole up and down stuff just between 0 and pi. Okay, the regular sine function has to go all the way out to 2 pi. I'm not going to draw it, but that up and down stuff goes all the way here, but this whole thing gets scrunched in here. All right, now A is -1. So I switch to maximum and minimum. The midline stays the same, which is still 0, 0, 0. Midline, midline, midline. But the max becomes the min. That means I start down to -1, and the min becomes the max. So that's y equals negative sine 2x. Okay, that's how you analyze this stuff. Okay, always refer back to this stuff here. All right. We'll do more. Okay, those were sines. Let me do some cosine ones for you. 7a, whoops. Y equals cosine 2 pi x. What's the a? What's the number in front of the cosine? Understood. 1. Okay. Amplitude is 1. Period is 2 pi divided by the b. The b is the coefficient in front of the x. 2 pi divided by 2 pi. 1. It's very nice. So one period just goes from 0 to 1. My basic cosine or sine function goes from -1 to 1. That doesn't change because the amplitude here is 1. Okay, so the range is still going to be -1 to 1. No change there. Oops, it came out crooked. So 1, -1, 1. Cut it in half, 1/2. Cut those in half, 1/4, 3/4. Right? My a is positive. So if a is positive, for cosine, I follow this. Maximum, midline, which is 0, minimum, midline, maximum. Okay, remember, this is really just one period. In actuality, it keeps going on both sides. It goes on forever. Just copy this, paste, paste, paste to the right, paste, paste, paste to the left, and so on. Okay.
I'm gonna search it up because I can't see anything.
Okay, B, -4 cosine 2 pi x.
I don't know what you just said.
Take a look at this. Okay, somebody please mute yourself. I hear somebody out there. Everybody please keep yourself muted. -4. So my A is -4. The period's going to be the same because the B is still the same. So the amplitude is the absolute value of -4, which is 4. The period is still 2 pi divided by 2 pi, which is 1, which means one period still goes from 0 to 1, but the range isn't going to be from -1 to 1. I multiply it by 4. It's 4 times -1 to 1, which is -4 to 4. So one period is still going to go from 0 to 1, but this thing goes higher and lower between -4 and 4. So here we go. So this is the same. One period. Cut it in half. Half. Cut that in half. 1/4. Cut that in half. 3/4. But now up and down is going to be 1, 2, 3, 4. 1, 2, 3, 4. Okay, my A is -4. So I have to switch max and min. Midline stays the same. So at the quarter mark and 3/4 mark, still 0. But max becomes min, min becomes max. So I start at the bottom this time. -4. Halfway, it used to be the minimum, now it's the maximum. And at the very end, maximum becomes min. So again, anytime A is negative for either sine or cosine, switch max and min, but the midlines stay the same. So there we go. Okay, so you can see there's a lot going on here. Okay, now we're going to start moving it left, right, up, or down. Okay, so 13, 15. Okay, so graph the function for one period. Okay, let's not worry about the intercepts. Okay, so skip intercepts and intervals where the function's increasing. So maybe I'll cross this out for the directions. I do want amplitude and period. Let's not worry about this. This kind of clouds the issue. I'm not going to worry about that. Okay, so I'm going to do 13 right now. Y equals sine x over 2 minus 2. When they write it like that, you should really think of it as this: sine of half x minus 2. Okay, A, B, there is no C, and there is a D. Amplitude is 1. Period is 2 pi divided by this. 2 pi divided by 1/2 dividing by a half is the same as multiplying by 2 4 pi. Vertical shift, 2 down. Vertical shift, 2 down. That changes my midline, which right now has always been y equals 0 or the x-axis. My midline is now y equals -2. Okay, so for all the ones that we've done so far, the midline was the x-axis, right in the middle. X-axis y equals 0, y equals 0, y equals 0, right in the middle. The midline, y equals 0. Okay, y equals 0. The only way it's going to change is if you do a vertical shift. If I go down 2, the midline becomes y equals -2. Okay, so one period isn't going to go from 0 to 2 pi, 0 to 4 pi. How about the range? Okay, the coefficient is 1, so I just take the regular -1, 1. But I subtract 2. Right? It used to be from -1 to 1. Move that all down 2. So -1 minus 2 is -3. 1 minus 2 is -1. So my new graph is going to go between y equals -3 and y equals -1, with y equals -2, my midline. And isn't -2 exactly halfway between -3 and -1? Right? So here's how this one looks. Let's see, all the y values are negative, so I'm going to skew my graph like so. Okay, way up here. So all these are going to be negative. Okay, one period goes out to 4 pi. That's very easy to cut it in 4 pieces, right? 2 pi, pi, 3 pi. Now remember, the regular sine or cosine finishes one period by the time it reaches 2 pi. This one stretches out. So this one stretches it out horizontally, goes all the way out to 4 pi. My range is -3 to -1, -1, -2, -3. Here's -1, -2, -3. So -2 is my new midline. Okay, I'm going to draw it just to make it easier to graph. Okay, just ever so lightly. I don't know if you can see it. I just drew a very tiny thing. Remember, this used to be the x-axis. All the previous ones, the midline was the x-axis, right? X-axis is right in the middle, y equals 0, right in the middle. But because I have this -2 here, the midline is y equals -2. Okay, now I'm ready. It's a sine type of curve. Okay, I can't keep switching back and forth, but the sine goes midline, max, midline, minimum, midline. So midline, -2, maximum, -1, back to the midline. See, it used to always be 0, but now it's -2. And then minimum, midline. So you see, there's a lot of things going on here, right? A lot of moving parts for these kind of problems. Okay, so we have to take account for all of these guys, the A, the B, the C, and the D. Okay. And let's account for the C, 17. Let's see, do I want to do that? Yeah, 17, cosine x plus 3. Whoops. Oops, pi over 3. My bad. Okay, the A is 1, the B is 1. The C is, well, actually negative pi over 3. Okay, so this is y equals cosine of x shifted pi over 3 to the left. Okay, remember it was counterintuitive, you might recall. X plus pi over 3, you don't move it to the right, you actually move it to the left. X minus pi over 3 is where you actually move it to the left. Okay, so essentially all that's happening is you take your basic cosine function. It doesn't go any higher or lower, doesn't change the period. I just pick this up and move the whole thing pi over 3 to the left. Okay, so how do I do that now? Okay, so the amplitude is 1. Period is 2 pi. The range is from -1 to 1. But this time for one period, well, what I'm used to is going from 0 to 2 pi, right? But you have to subtract pi over 3, which is a little bit clumsy, okay? And in order to do that, I'm going to write 2 pi as 6 pi over 3. So I can get a common denominator. 6 pi over 3 is the same as 2 pi, right? Okay, now what's 0 minus pi over 3? Negative pi over 3. And then 6 pi over 3 minus pi over 3 is 5 pi over 3. So I'm going to go from negative pi over 3 to 5 pi over 3 for one period, which is much more clumsy. And essentially, for all of the marks that I'm quote unquote used to, I have to subtract pi over 3 from all of them also. Okay. So in other words, the standard cosine function that we have are 0, pi over 2, pi, 3 pi over 2, and 2 pi. I have to subtract pi over 3 from all of them. Okay, so 0 minus pi over 3, we already know is negative pi over 3, right? But I have to subtract pi over 3 from all the other guys also. So I need pi over 2 minus pi over 3, which is common denominator 6. Multiply that by 3, 3, 2, 2. 3 pi minus 2 pi is pi. So that's my 1/4 mark. Okay, so pi over 2 minus pi over 3 is pi over 6. Common denominator is 6 multiplied by 3 over 3, 2 over 2. Okay, then the mid halfway point was pi. Pi minus pi over 6 is 5 pi over 6. Common denominator again is 6 times 6. 6 pi minus pi, 5 pi. 3 pi over 2 minus pi over 3. Common denominator is 6 times 2 times 2 times 3 times 3. So 3 times 3 is 9 pi minus 2 pi, 7 pi over 6. And yeah, we already did 2 pi minus pi over 3 was 5 pi over 3. So it's quite clumsy, as you can see. So this is my beginning part, 1/4, half, 3/4, whole thing. Okay, so I do have a negative here, so I have to go over a little bit. So eyeballing it, this is negative pi over 3. And then the rest are all positive at least. So pi over 6, 1/4 of the way. Five pi over 6. Oops, I don't think something's not right here. Something's not right here. Okay, well, yeah, I think I messed up here somewhere, but let me go with it right now. I can see it's not matching up. So I messed up somewhere. If I can figure it out, I'll tell you. Let me just put these down for now. 5 pi over 6, 7 pi over 6, and 5 pi over 3, 1, -1. I'm pretty sure that's wrong because the distance from here to here isn't the same as the distance from here to here. So I messed up somewhere. Okay, and we are doing cosine. So cosine goes maximum, midline, minimum, midline, maximum. Go like that. Okay. Right, so that's what we're up against. Okay, so it's almost noon. Let's take our usual break. I'll try to figure out what happened here, and we'll start again at 12:10 as usual. Okay. All right, break time until 12:10. Okay, folks, let's continue on with where we were. Okay, first I found out where I messed up over here. When I was doing pi minus, I originally put pi over 6. I don't know why. Of course, I was supposed to subtract pi over 3 like I did for all the others. Okay, so if you do it the right way, it should be 2 pi over 3. Okay, so it's negative pi over 3, pi over 6, 2 pi over 3, 7 pi over 6, and then 5 pi over 3. So please change this to 2 pi over 3, and the rest is okay. All right, the next thing I want to show you is something like 21, because that's a good example of how I don't want you to do it the way the book has it. All right, this is the way the book has it. There's a way you can do it like that, but I don't want you to use it that way. I want you to make the equations always look like this, where you factor out the coefficient. What does that mean? Take the coefficient of x outside, 3x plus like that. Okay. Now, how do you figure out what to put over here? Well, you take out a 3. So you're going to be multiplying by 3. So if I multiply this by 3, in other words, 3 times whatever this is going to be that. I want 1/3 of this value. Okay, so scratch paper, what is 1/3 of pi over 2? It's pi over 6. Okay, one more time, the logic. I'm factoring out the 3. I want it to look like this. So it's going to end up 3 times something is pi over 2. That means I have to take 1/3 of this or divide by 3. Here it's easier to say multiply by 1/3 pi over 6. In other words, make it look like this. Double check if you're not convinced of that. 3 times x is 3x. What is 3 times pi over 6? Pi over 2. So it works. Okay, amplitude is 1. There's no number in front, or you can say it's 1. The period is 2 pi divided by b, 3. No change in the range. -1 to 1. But again, I have a shift of pi over 6 to the left. Shift pi over 6 to the left. So one period is ordinarily going to go from 0 to 2 pi over 3. But I subtract pi over 6 from everything. Okay, how do I do that? Fortunately, in this case, it's actually not that bad. I think I'll show you why. One period, if I didn't have the shift, the horizontal shift, I go from 0 to 2 pi over 3. What's half of 2 pi over 3? 1 pi over 3. Half of pi over 3, pi over 6. Now I can go pi over 6, 2 pi over 6, 3 pi over 6, 3 pi over 6, right? 4 pi over 6. I take all of this and shift pi over 6 left. But very fortunately, all of these are already pi over 6 units, aren't they? Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So when I move back pi over 6, I just move 0 to negative pi over 6, and the rest just land directly on these. So it's not so bad after all. Okay, so we're ready for the entire graph. So for one period, it's going to be negative pi over 6, 0, pi over 6 is halfway, 2 pi over 6, pi over 3, and 3 pi over 6, pi over 2, ends one period. There we go. The range is negative 1 to 1, minimum and maximum. It's a sine type of function. So we're good to go. Sine starts at the midline. So that's the sine, midline, maximum, midline, minimum, midline. Midline, in this case, is 0. Maximum, midline, minimum, midline. So that's the graph that I want in this case. Okay. Okay, let's make it look a little bit more complicated. 29. So tomorrow's quiz, you're going to get stuff like this. Okay. But of course, you can help each other out as normal. Y equals cosine 2x minus pi over 3 plus 1. Uh-huh. Right, so factor out the 2. Which means I want half of this, right? To balance it out, if I'm going to multiply by 2, I multiply by half. What's half of pi over 3? Pi over 6. Amplitude, there's no number in front, 1. Period is 2 pi divided by b. Strictly speaking, absolute value of b, but it's almost always going to be positive. So 2 pi divided by 2, which is pi. This one has a horizontal and vertical shift, right? Shift is pi over 6 to the right. 1 up. So where am I going to get 1 period? If I didn't have a horizontal shift, it'd be from 0 to pi. But I have to add pi over 6. Pi is like 6 pi over 6. So 0 plus pi over 6 is pi over 6. Pi plus pi over 6, 7 pi over 6. So this is where I'm going to get my 1 period. from pi over 6 to 7 pi over 6. It's supposed to be 0 to pi, but the whole graph gets shifted pi over 6 to the right. What's the new range? Okay. Since I have no coefficient here, or you can say it's 1, it's the regular range of -1 to 1, but the whole thing gets shifted 1 up. So if I add 1 to -1, I get 0. If I add 1 to 1, I have 2. So my range is 0 to 2 with y equals 1, my new midline. The midline is basically going to be whatever you add or subtract here as y equals that number. That's my new midline. Right. Now I have to compute where I'm at. Okay. So one period is from 0 to pi. Get a little bit more space here. So 0, pi, pi over 2, pi over 4, 3 pi over 4. So this would normally be my beginning, quarter mark, halfway mark, 3/4 mark, all the way through. 0, pi over 4, pi over 2, 3 pi over 4 pi. All of those I have to add pi over 6. Plus pi over 6. We already know that's pi over 6. I already did the last one. 7 pi over 6. So these I have to add pi over 6. So pi over 4 plus pi over 6. So scratch paper, pi over 4 plus pi over 6. Common denominator would be 12. So times 3 times 3 times 2 times 2. 3 pi plus 2 pi, 5 pi over 12. Pi over 2 plus pi over 6, scratch paper, pi over 2 plus pi over 6, common denominator 6, times 3 times 3, 3 pi plus pi, 4 pi over 6, which reduces to 2 pi over 3. So halfway through, 2 pi over 3. And finally, 3 pi over 4 plus pi over 6. Remember, we're moving the whole graph according to this, pi over 6 to the right. So my beginning mark, quarter mark, halfway mark, 3/4 of the mark, and end of the mark all have to be added by pi over 6. So scratch paper, 3 pi over 4 plus pi over 6. 3 pi over 4 plus pi over 6. Common denominator is 12. So multiply this by 3 times 3 times 2 times 2. So that's 9 pi plus 2 pi, 11 pi over 12. So we have some funny values that we don't recognize. That's the way we're going to have to do it. Okay. So I start at pi over 6, not 0, my familiar place. Pi over 6, 1, 2, 3, 4. And then I put down these funny numbers, 5 pi over 12, 2 pi over 3, 11 pi over 12, 7 pi over 6. My range is from 0 to 2. So 0 is my minimum, 2 is my maximum, y equals 1 is my midline. Midline. We're doing cosine. A is not negative, it's positive. So I don't have to switch them like that other one. Okay, so cosine goes max, midline, minimum, midline, max. Maximum is 2. Midline, minimum, midline, maximum. There's one period. Okay. Definitely a lot going on. Remember, that's just one period. In reality, this thing keeps going on and on and on, and this keeps going on and on and on. It's periodic, which means you can copy and paste, paste, paste. It pastes forever to the left and to the right. Okay. So that's how you do that. Okay, for 33 and on, okay, skip graphing utilities. Okay. So never mind about B, C, and D. Okay, maybe I'll just emphasize it by just going like that. Okay. Only do part A. Amplitude, period, phase shift, so on. Okay, so how do we do that? Okay, so how about I'll set you up for 33? It's not going to be that nice. Y equals negative 2.5 cosine 3 pi x plus 4. Factor out the 3 pi. So if I take out a 3 pi, I divide by 3 pi. Four over 3 pi. Okay, now there's no way we can know what this is exactly. Okay, so we'll just do a decimal approximation. Okay, so I'll just punch out 4 divided by 3 pi. 4 divided by parentheses 3 pi. .424. So it's a shift of 0.424 to the left. Amplitude is the absolute value of A. A is the coefficient of the cosine function here. So absolute value of negative 2.5 is 2.5. Period is 2 pi divided by B. 2 pi divided by 3 pi is just 2/3. Which is about 0.67. All right, so to graph this one, they say just do approximately. Okay, so for one period, is from 0 to 0.67, except I have to subtract 0.424, which is very awkward. So this is negative 0.424. And then what is 0.67? 0.67 minus 0.424. 0.246. Now, how am I going to get all the other numbers? In this case, maybe it's easy if we just average the two to get the halfway part. Okay, so negative 0.424, 0.246. Rather than trying to do it the way we did before, the average of these two numbers would be halfway, right? So why don't I just average the two? It looks like it'll be negative. So 0.246 minus 0.424 divided by 2. Negative point, let's see. Negative 0.089. I just average these two. And now average these two. It's easier if I just do the positive. So 0.424 plus 0.089, divide that by 2, and just put a negative 0.26. And then halfway here, I'll average those two. 0.246 minus 0.089. Divide that by 2. Call it 0.08. Okay, so I know it starts here, it ends here, halfway's in the middle. And then I just went halfway between these two to get the quarter mark, and halfway between these two to get the 3/4 mark. Okay, I do not have a vertical shift. So my range is going to be from negative 2.5 to 2.5. Negative 2.5 to 2.5. Okay, so this is a rather clumsy graph. Negative 0.42. So there's more negative here than positive. Let me make my graph like so. It needs to have enough space for the negative side, right? Well, this is pretty close to 0. I'll just go like that. And like that. And like that. And like that. And like that. Okay. So these are these numbers here. I'm not going to write them in because it takes up too much space. But that's the beginning point, quarter mark, halfway, 3/4, and the end. 1, 2, 3. 1, 2, 3. Okay. I go up to 2.5. So let me mark off 2.5, which is maybe there, and negative 2.5. Okay, so I start here, I end here. It's cosine, and there's a negative. So negative means I reverse the max and min. So instead of starting at the lowest point, instead of starting at the highest point, I start at the lowest point. Okay. So lowest point, midline, maximum, midline, minimum. Okay, so that was definitely a little bit tougher. Right, so you can see that we're factoring out in these cases that I have here. Okay, we'll try a few more. Let's see. Try 37 for you. Y equals sine 0.5x plus 0.75. Factor out the 0.5. If I multiply by 0.5 here, I divide by 0.5 here. Comes out to be 1.5. Another way to think of it is 0.5 is like a half, right? Half of 1.5 is 0.75. It works. Amplitude is 1. Period is 2 pi divided by 0.5. 4 pi. Shift 1.5 left. Again, that's not going to be nice. Fortunately, this is pretty easy to divide into 4, right? How do you split 4 pi into 4? Well, from 0, pi, 2 pi, 3 pi, 4 pi. So 0, pi, 2 pi, 3 pi, 4 pi. Beginning, quarter mark, halfway, 3/4, full. Okay. So that's one period, but each of these have to subtract 1.5. And so we just do this approximately. Well, I don't need a calculator for that. That's negative 1.5. Okay. All the others, just punch it in. Okay. And by the way, most calculators now have a pi button. If you don't have a pi button, then just do 3.14. But you know, we got the pi button, might as well use it. So pi minus 1.5, 1.64. And 2 pi, is that 4.78? And 3 pi minus 1.5, 7.92. And 4 pi minus 1.5, 11.07. Okay, amplitude is 1, so I'm still only going from -1 to 1. Negative 1.5, 1.64, 4.78, 7.92, 11.07. Amplitude is 1, up 1, down 1. Midline is still the x-axis. I draw a sine type curve. A is positive, so I just follow the rules for the sine function. Okay. Sine goes midline, maximum, midline, minimum, midline. Minimum, sorry, midline, maximum, midline, minimum, midline. And here we go. All right, so be ready to do this kind of stuff for the quiz tomorrow. I'm probably not going to give you anything with these approximations that came out too weird. Okay, but any of the earlier ones would be fair game. Okay, so I might give you something where all of these are involved. So most likely I'll have you do 2, one sine and one cosine. Okay, so there's a number here, number here, number here, number here. Maybe I'll give you one sine, one cosine. Right, so the amplitude is the absolute value of this. Watch out if it's positive or negative. Maybe I'll give you one of each. Period is 2 pi divided by this. Horizontal shift, vertical shift. You can follow these rules over here. Okay. All right, then let's see, 41 and 43, and then that's pretty much about it. I'm going to do 41 for you. 41. Is it a sine bx or a cosine bx? And find the values of a and b. Okay. So 41, you can see it there. pi over 3, 1.5. All right, starts at the origin. So is that sine or cosine? Which one starts at the origin? Sine. Sine of something. 1.5 is the high point. So the amplitude is 1.5. It starts up, so the coefficient is 1.5. How do I find the b? Let's get the period. What fraction of the whole thing is this point that they give me? Like, is it halfway, 3/4 of the way? 1/4 of the way, right? 1/4, 1/2, 3/4, the whole thing. So the period is all the way here. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So the period is 4 pi over 3. Right? Okay, this is the quarter mark. The x coordinate is pi over 3. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. By formula, that's 2 pi over b. And strictly speaking, it's absolute value of b, but let's just leave it as b. Solve for b. I'll cross multiply. 4 pi b is equal to 6 pi. Divide both sides by 4 pi. 4 pi, cancel, cancel. B is 3/2. So y equals a sine bx. In this case, the a we found to be 1.5 amplitude. Sine of 3/2 x. And there we go. I'll give you 43 also. And I think that's the last one, right? 43. Yeah, so that's the last one. So I'll mark it off. Okay, so I'll be done after I finish 43. So if anybody has any questions, you can ask it. Otherwise, we'll just quit. So I'll be done in maybe less than 5 minutes. 43 looks like that. Looks like the midline is the x-axis, ends at 5, 1. Right, this one looks like it starts at the top, not at 0. So is it sine or cosine? It's going to be cosine, right? Well, the highest value is 1, the lowest is -1. So the amplitude is 1, which means A is 1. What's the period? Well, from here to here, this is the end of the one period, so it's 5. 2 pi divided by b. Multiply both sides by b. 5b equals 2 pi. Divide by 5. B is 2 pi over 5. Right, so y equals a cosine EX. A is 1. B is this funny thing. So I'm done. Y equals 1, but if it's 1, you don't have to write it. Cosine of 2 pi over 5x. And there we go. All right, let me go back and do my focus job, but otherwise I'm done. Okay, so focusing on this, and this is actually the third page that I wrote on. So let me go back and show you the other ones too, in case I forgot to do that. Okay, so the other stuff that I wrote. So any questions, you can either unmute yourself or put it in the chat. Otherwise, after I show you this, we're done. So be ready for a couple of these graphs tomorrow. I'll probably give you one sine, one cosine, maybe one where the A is positive, one where the A is negative. And I try to give you plenty of time for it because I know these can sometimes be real long to do. Okay, so that was actually the first page, and now this is the second page. So sorry, I'm kind of out of order here, but hopefully you can figure it out. That, and then all of this stuff. And there we go. Okay, so tomorrow's lesson is not really that long. Okay. 8.4 is only 1 to 5. It doesn't take that long to do it. So I was hoping and I was planning to give you quite a bit of time for the graphs because they take so long. So you might even get more than an hour to do it. Then it's all done and then we're off for a week. Okay, so then remember after we come back from spring break, we have to finish 8.5 and then that Thursday will be exam 4. I'm pretty sure we're not gonna have the next test on this day. Whenever it is, I'll let you know when we get to it. Okay, all right, that's it for today, folks. Anybody have any questions? Otherwise, that's it. All right, so have a good rest of the day and we'll see you next time. Okay, all right, bye everybody. Have a good day.